The Atlantic Ocean in 1942 was a silent battlefield. No trenches, no roaring artillery, no shouting soldiers, just cold water and the shadows of steel predators gliding beneath the waves. Allied convoys feared them. Merchant sailors prayed not to meet them. And somewhere in London's intelligence offices, analysts pinned red dots on maps, showing yet another ship lost. These predators were the German U-boats, Hitler's gray wolves. Their mission was simple, brutal, and devastating. Starve Britain by sinking everything that floated. But deep within that campaign of torpedoes and terror, a mystery began to gnaw at Allied engineers and naval planners. German submarines were feared for being advanced, quiet, deadly, machines built with almost obsessive precision. At least, that was what Allied officers believed. And then one stormy week in late 1942, an opportunity surfaced, literally. A disabled Type 7 U-boat, battered by depth charges and abandoned by its crew, drifted into Allied reach. Its conning tower jutted from the waves like a steel tombstone. Its engines were silent. Its hatches were open. It was a ghost ship, but a priceless one. Within hours, salvage teams rushed in. But it wasn't the sailors or even the engineers who were most excited. It was the divers, the men who risked freezing water, crushing pressure, and the unknown dangers lurking inside the hull. For them, this wasn't just another wreck. This was their chance to peer into the heart of the German U-boat menace. Their chance to see with their own eyes how the enemy built these deadly machines. Yet what they found underwater would challenge everything they thought they knew. Before that discovery, Allied intelligence had a very specific idea of German manufacturing. Tight tolerances, perfect symmetry, flawless welding. The kind of engineering that produced weapons like the Bf-109, the Tiger tank, and the V-2 rocket. So naturally, Allied officers assumed the same level of craftsmanship existed in U-boats. But the truth was far more complicated. To understand what those divers saw, we have to rewind the story. Back to the early days of the war, when German shipyards were under immense pressure. The Kriegsmarine had big dreams. Dozens, then hundreds of submarines to strangle Allied supply lines. But those dreams ran into a hard, immovable wall. Time. Germany didn't have the years needed to carefully craft each submarine to perfection. They needed mass production. They needed speed. And so, under that pressure, something began to crack, literally. German shipyards began cutting corners. Welding teams were pushed to their limits. Young, inexperienced workers were brought in, and quality control, once a proud German hallmark, was stretched so thin that entire sections slipped through unchecked. Yet none of this was visible to the Allies. From the outside, U-boats looked sleek and dangerous. They dove deep, they killed mercilessly, and they vanished. But divers would soon discover the truth beneath the surface. The captured U-boat, dragged into a secure harbor under heavy guard, became the center of one of the most secretive inspections of the war. Above the surface, engineers swarmed over it, sketching every bolt, every pipe, every switch. But below the surface, in the cold darkness, the divers began their descent. For many of them, this was the most dangerous kind of dive. A submarine's hull is not smooth inside. There are pipes, sharp edges, cables, and bulkheads. Any one of them a snag that could trap a diver forever. And the silt that filled the submarine made visibility almost zero. It was like stepping into the belly of a sleeping iron beast. The first diver in was Chief Petty Officer Jack Mallory, a man with nerves of steel and a lifetime of deep water experience. As he moved along the bow, his flashlight beams skimmed the hull. At first, he thought a trick of the light distorted the metal. But when he swam closer, he saw it clearly. The weld seams were terrible, rough, uneven. Some were cracked. Others looked like they'd been repaired in a hurry. And a few spots, unbelievably, seemed to have been filled with a different type of metal entirely, as if someone patched them with whatever they had on hand. This wasn't high German precision. This wasn't master craftsmanship. This was crude. Mallory surfaced, tore off his mask, and shouted the moment he caught his breath. The officers on deck expected news of advanced torpedo tech, some new stealth coating, a hidden sensor, anything. But instead, what he reported was simple. Their welding is awful. I've seen fishing boats built better. His words stunned the officers. At first, they didn't believe him. This was the German Navy, the perfect war machine. But when more divers went down, the findings repeated. Poor welds, gaps, sloppy reinforcements. It didn't make sense, but it would soon, because those crude welds explained everything. They explained why so many U-boats collapsed at depth, why some never resurfaced after routine dives, why German crews whispered about cursed boats that groan like old ships, and why some U-boats simply vanished without Allied contact. What Mallory found was not just a flaw. It was a crack in the myth of German invincibility. And as engineers gathered around the divers' findings, one question grew louder. What else were the Allies wrong about? The answer would reshape their entire underwater war strategy. The moment the divers confirmed the crude welding, the U-boat stopped being just a curiosity. It became a puzzle that demanded solving. Engineers, metallurgists, and naval architects gathered around chalkboards, sketching diagrams and arguing about what these sloppy seams meant. But to get real answers, they needed more than surface observations. They needed to crawl inside the submarine skeleton, inside the metal itself. That's when the deeper dives began. The second dive team arrived the next morning. Unlike the first group, whose mission was purely exploratory, this team brought tools. Chisels, hammers, metal samplers, underwater lamps. Their orders were simple: bring back pieces of the hull. But inside the cramped, water-filled compartments, every movement felt heavy and dangerous. The silt from the seabed floated in thick clouds that swallowed light. Each diver had to feel their way through tight spaces, brushing against pipes and valves that had long since gone silent. One diver, Lieutenant Mark Halpern, later described the sensation as crawling to the throat of a steel animal while blindfolded. But the risk was worth it, because as Halpern moved along the pressure hull, he noticed something even stranger than bad welding. Many of the seams had been welded more than once. The metal around them looked scorched, as if someone at some point had tried desperately to fix cracks that kept reappearing. And in some areas, the patchwork repairs were so crude that the welded metal looked like melted candle wax. When the divers finally resurfaced and delivered samples to the engineering team, the tests confirmed their suspicions. The welds were brittle. Some sections had microfractures. Others had been welded with low-grade filler metal, the kind used only in emergencies. And worst of all, several seams seemed to have been rushed with poor penetration, meaning the metal was fused only on the surface, not deep enough to withstand the massive pressures of the deep ocean. This discovery overturned years of Allied assumptions. Until now, commanders had believed U-boats could dive safely to 200 meters or more, giving them a huge advantage when evading depth charges. But these welds told a different story. Many U-boats, especially those built quickly or repaired in stressed shipyards, were far weaker than expected. Their collapsed depth might be much shallower, maybe even dangerously so for their own crews. Suddenly, a terrifying question emerged. How many German submariners had died not from Allied attacks, but from their own hulls giving way? As engineers debated the implications, intelligence officers stepped into fray. They asked a question of their own: why were German welds so poor? To find that answer, the Allies began piecing together intercepted documents, spy reports, and interviews with prisoners of war. Gradually, the picture became clearer and darker. In 1941 and 1942, German shipyards were operating at a frantic pace. Hitler demanded more U-boats faster. Skilled welders were scarce, many having been drafted into other industries or military units. In their place came teenage apprentices, civilian laborers with minimal training, and sometimes forced laborers who had no experience at all. Supervisors were ordered to prioritize speed over quality. For every U-boat that rolled out of shipyard, another two were already behind schedule, and as pressure increased, shortcuts became routine. Allied intelligence officers discovered reports from inside German shipyards detailing everything from faulty welds to misaligned hull sections. In some cases, entire U-boats were launched before their welds were properly tested. The myth of German industrial perfection began to shatter. But the divers were not finished uncovering surprises. During a later dive inside the aft section of the captured submarine, Halpern noticed something odd near the bulkhead. A hole, perfectly circular, about the width of a coin, buried under a sloppy patch of weld metal. It didn't look like battle damage. It looked intentional. When he brought a sample of that area to the engineers, they discovered something shocking. The hole had likely formed because of a burn-through, caused when an inexperienced welder used too much heat in one spot. But instead of replacing the metal, the welder simply patched it from the outside, leaving the burn hidden beneath layers of sloppy weld. That discovery chilled everyone who reviewed the report. If the submarine had ever attempted a deep dive, that thinly patched area could have ruptured instantly, killing the entire crew in seconds. The divers continued mapping the hull for days. Every dive revealed more imperfections. Misaligned joints, weld spatter left uncleaned, even places where the welding bead stopped abruptly, as if the welder had simply walked away mid-task. Yet inside this chaos, the Allies found opportunity, because once they understood how fragile many U-boats actually were, they could rethink the entire underwater war. Depth charges could be set to explode at shallower depths. Pressure waves could cause hull collapse even without direct hits. And convoy commanders could take bolder actions knowing U-boats were not the indestructible sharks they once seemed. Still, one question lingered over the entire investigation like a shadow. If the welds were so bad, how had U-boats been so deadly? The answer came from another piece of intelligence. German naval designers had compensated for crude construction by relying heavily on tactics. U-boats rarely dove deep unless absolutely necessary. Instead, they attacked on the surface at night, where the crude welds didn't matter. Their strength wasn't in engineering excellence, but in strategy and surprise. This realization changed everything. It meant the Allies were not fighting superweapons. They were fighting clever tactics wrapped in imperfect steel. Now the stage was set for the climax of this investigation, where one final discovery would link every mystery together and expose the truth behind the U-boat war. The final breakthrough in the U-boat investigation began almost by accident. A week after the divers completed their surveys, a team of British naval architects rolled the submarine into a dry dock, drained the water, and climbed inside the hull to begin a full structural analysis. What they found would become the missing piece of the puzzle, and the most shocking revelation of the entire operation. Deep inside the pressure hull, along the keel, lay a long internal seam that the divers had not been able to reach. To the naked eye, it looked solid, smooth, even respectable compared to the other welds. But something about it felt wrong. Lieutenant Halpern, curious, ran his hand along the metal. It felt thin, too thin for a pressure-critical area. A weak spot in the backbone of a submarine. He marked the section with chalk. Engineers brought cutting torches and slowly opened the seam. And when the plates separated, a truth emerged that none of them expected. There was no real weld at all. The plates had been tacked together, barely fused at the edges, while the center was filled with shims and metal scraps hammered into place, like stuffing newspaper into a cracked window frame. Gasps echoed through the hull. This wasn't incompetence. This wasn't rushed labor. This was desperation. The engineers realized the truth instantly. The shipyard must have run out of welding rods or filler metal during construction. Instead of delaying the launch, something the Kriegsmarine would not tolerate, the workers improvised. They forced scrap metal into the gap, tacked the plates shut, and hoped no one would ever inspect it closely. It was a hidden death sentence, a failure waiting to happen, a structural bomb ticking inside the submarine. And suddenly, all the past mysteries the Allies had encountered over the years snapped into place. The seemingly random disappearances of U-boats, the reports from German prisoners of boats that creaked like haunted ships below 80 meters, even the frantic emergency repairs seen on other capture hulls. Everything pointed to a fleet built on a fragile foundation. The German U-boat threat had been real, but also dangerously flawed from within. This discovery triggered immediate action at the highest levels of Allied naval command. Depth charge strategies were redesigned within days. Instead of wasting charges on extreme depths, captains were instructed to detonate patterns above 100 meters, where a compromised hull stood no chance. Hunters in the Atlantic suddenly had a new advantage. They didn't need a perfect hit anymore. A close explosion could create pressure waves strong enough to shatter a weak seam, and the results were almost immediate. Over the next months, U-boat losses climbed. British and American destroyers reported more kills with fewer depth charges. Submarines that previously escaped now suffered catastrophic hull failures mid-dive. The Allies didn't know which U-boats had the worst welding, but now they didn't need to. They had turned the enemy's own weaknesses into a weapon. But the revelations didn't end there. As engineers completed their full examination of the captured U-boat, another pattern emerged. Many of the poor welds appeared in specific sections, areas traditionally outsourced to satellite shipyards under wartime contracts. These smaller facilities lacked experienced foremen and used whatever materials they could acquire through rationing shortages. Some even suffered sabotage by laborers forced to work for the Nazis. The Allies realized something profound. The German war machine, often portrayed as flawless, was fracturing under its own weight. The pressure of mass production had eaten through quality. The relentless pace demanded by Hitler's naval command had turned once skilled shipyards into assembly lines held together by hope, fear, and scrap metal. It wasn't German genius the Allies had been fighting. It was German desperation. As the investigation wrapped up, Chief Petty Officer Jack Mallory, the first diver to descend into the submarine, returned to see the dry dock hull one last time. He ran his hand along the jagged metal, its scars exposed by bright dockyard lights. He had spent years imagining U-boats as perfect predators, crafted with terrifying precision. Seeing one cut open like this, it felt like looking behind the curtain of a myth. A naval historian present that day recorded his comment. It's strange. For years they scared us. And all this time, they were just as scared of their own machines. In the final report submitted to Allied High Command, the engineering team summarized their findings with remarkable bluntness. The enemy submarines are deadly not because of superior design, but because of opportunistic tactics and the willingness to risk failure. Their hulls show widespread evidence of poor welding, rushed construction, and dangerous improvisation. This report was classified for decades. After the war, when Germany's surviving U-boat crews read accounts of these investigations, many were stunned. Some had suspected structural flaws, especially when hearing the groans and metallic pops that echoed to the hull during dives. Others had never imagined that the steel around them had been held together by welders who lacked experience, or by shipyards forced to cut corners under impossible schedules. In a twist of irony, many former U-boat captains admitted that they rarely pushed their submarines beyond 100 meters unless absolutely necessary. Instinct, fear, or experience had told them what Allied engineers would only confirm years later. Their boats were not the deep-diving beast propaganda claimed. As for the divers, their work became a quiet but essential chapter in the Battle of the Atlantic. Their discovery reshaped the entire underwater war, saving countless Allied sailors and hastening the end of Germany's submarine campaign. Yet their efforts remained unsung for years, overshadowed by more dramatic victories. But the truth is this: while destroyers and depth charges won battles, it was the divers and the crude welds they uncovered who changed the war. And in that cold, silent harbor where a captured U-boat once rested like a steel corpse, a myth died. A myth of perfect German engineering. A myth of invincible submarines. What remained was the truth. The wolf pack wasn't made of steel perfection. It was made of fear, rushed hands, and cracks waiting to break.